Good morning, all of you. Today I will start with work, energy, and power. Now, in physics, for a general people, if I ask you what is work, so for common people, running, walking, eating, blinking of eyes, reading book, all this comes, they will say that it is work. But according to physics, work is said to be done only if when we apply force, or you can say when the force is applied on an object and the object is displaced from its original position, then only work is said to be done. If we will not apply force, there will be no work done. If the body, on applying force, the body will not get displaced, then also no work will be done. It is actually equal to product of force and displacement. So W, if we represent work by W equals to product of force and displacement. So F dot S, it is dot product of force and displacement. So this is equals to Fs cos theta, where theta is the angle between force applied and the displacement. Work is scalar quantity. Its SI unit is joule. How we will define 1 joule? 1 joule of work is said to be done on an object when a force of 1 Newton displaces it by 1 meter in the direction of force applied. I am repeating again, 1 joule of work is said to be done when a force of 1 Newton displaces that body by 1 meter in the direction of force applied. Now we can classify work as positive work done, negative work done, and zero work done. Positive work done, work is said to be positive if the force and displacement are in the same direction. Consider a body at position A. Let F is the force applied. On application of force on the body A, let you just take a body on the table. Let the body moves from position A to position B, moving through a distance S. Now, what is the angle between the force applied and the displacement? It is 0 degree because both are in the same direction. So cos 0 will be equal to 1. Theta is 0 degree. Cos 0 equals to 1. So work done equals to Fs cos 0. This is equals to Fs. Work done is said to be positive when force and displacement are in the same direction, and you are getting F equals to Fs. Now negative work done. Negative work done by a force is said to be negative if the force and displacement are in opposite direction. Consider a body at position A. We have applied force in this direction toward right. Let the displacement is toward left, right? Displacement is toward left. What will happen on application of force? The force you are applying in one direction, but the displacement is in other direction. Here theta is 180 degree. So work done is equals to Fs cos 180 degree. Cos 180 is minus 1. So you are getting W equals to minus Fs. Now zero work done, I will give you some examples of both positive, negative and zero work done. First come to zero work done. When force is causing no displacement. When we apply force, but the displacement will not be there. So S will be 0 in that case and work done will be 0. Now work done, one more example you can take here. When no displacement is there, no work done. Second, when force is acting perpendicular to the displacement, then also the work done will be 0. In this case, theta will be equals to the angle between force and the displacement is 90 degree and cos 90 equals to 0. So work done will be 0. Example of positive work done. When we throw a stone in upward direction, The applied force, right? So when we throw a stone in upward direction, the force is acting in upward direction. The displacement is also in upward direction. So work done will be positive. Another example, when we kick a ball and the ball moves in the direction of force applied, then the work done is positive. Come to negative work done, when we push a box, right? When we apply force on a box in one particular direction, the force of friction will act in the opposite to the direction of motion of body. So the work done by force of friction will be negative. Another example, when we throw a stone in upward direction, the force of gravity will act in downward direction. When we throw the stone in upward direction, applied force is in upward direction, displacement is in upward direction, but the force of gravity is acting in downward direction. So work done by the force of gravity is negative. Zero work done, when we apply force on a wall and the wall does not move. So work done will be zero. Here displacement is zero. Another example, take a stone, tie a string and drill the stone. You will find that work done here will be zero because the force is acting toward the central. The centripetal force is acting toward the center and the displacement is given by the tangent to that point. Angle between the two is 90 degree. So work done will be cos 90 is zero. So work done will be zero. Now let us do some numerical based on work done. A man weighs 70 kg, carries a weight of 10 kg on the top of a tower 100-meter high. Here the mass of the man is 70 kg. He carries a weight of 10 kg and he is moving on the top of tower which is 100-meter high. So height here is 100 meter. Mass of the weight that he is carrying, calculate the work done by him. So what is the work done by him? Come to the solution. Mass of the man 70 kg, mass of the object 10 kg, total mass 70 plus 10, it is 80 kg. Height of the tower is 100 meter. So work done is equals to force into displacement. In place of F, you can write M into G, and in place of S, you can write H. So mass here is 80. G is, we can take 10 if it is not mentioned to take 9.8, and H is 100 meter. So when you multiply it, you are getting 80,000 as if you are finding out work. So unit will be joule. Next, number 2. An engine pulls a train 1 kilometer over a level track. Distance covered is 1 kilometer, that is 1000 meter. Calculate the work done by the train given that the frictional resistance is 5 into 10 to the power minus 5 Newton. Here frictional resistance, so F will be equals to minus 5 into 10 to the power 5 Newton. And S is given 10 to the power 3 meter. So find out work done. W will be equals to F dot S. F is minus 5 into 10 to the power 5 and into 10 to the power 3, that is displacement. This is equals to minus 5 into 10 to the power 8. Write down joule here. Work done, always express the unit in SI unit, that is joule. Now number 3, a boy of mass 55 kg runs up a flight of 40 stairs, each measuring 0.15 meter. Calculate the work done by the boy. Mass of the boy is 55, right? Runs up a flight of 40 stairs. Number of stairs is 40, each measuring 0.15 meter. So total displacement will be 40 into 0.15. Calculate the work done. W equals to force into displacement. Force here is M into G, and displacement here is 40 into 0.5. Now come to the solution. M equals to 55. Displacement is equals to mass of the boy is 55 kg. Displacement is 0.50 into 40, that is coming 6 meter. Work done equals to force into displacement, that is 55 into G. G is 10 into 6. S is 6. When you multiply, you are getting 3,300 joule. Number 4, a coolie carries a load of 50 kg on his head and walks on a level road up to 100 meter. What is the work done? Mass of the load is 50 kg and he is walking on the level road. So weight is acting in downward direction and he is moving 100 meter. The angle between the displacement and the weight carries is 90 degree. So cos 90 will be 0 and work done will be 0. Work done here is 0 since the angle between the weight of the coolie, weight that the coolie carries and displacement is 90 degree. So work done will be equals to Fs cos 90. Cos 90 is 0. So work done will be 0. Thank you. Have a nice day. Next day I will start with energy.